Good afternoon, everybody. Today I am going to present my paper titled Distributed DOS Attack Detection from Optimal Feature Set in eHealth Cloud Environment, a module using the LSTM. Myself, ANINDYA BOSE. I am Assistant Professor, Department of Cyber Science and Technology, Brainware University. So basically, I am coming to the introduction part of my presentation. Distributed denial of service. That is a very common type of cyber attack in the cloud uh, computing scenario. And though the healthcare cloud was comparatively immune to attack, in recent times there had been instances of distributed DOS attack which caused a lot of damage. So it is essential to identify the attacks at the earliest. And in this work, in my work, basically, I focused basically three types of distributed DOS attacks. One is the ICMP flooding, TCP-SYN flooding, and land flood attack, especially in the health cloud environment. And I compared the result with the outcome of the different machine learning algorithms and proposed a system through which we can get a better performance, better result out of these three attacks. Now, basically, security threats, if we consider, already I have discussed that I focused in three basically attacks. One is the ICMP flooding, TCP-SYN flooding, and land flooding. So before going to discuss, before going to next slide, so I should first clarify these attacks. The first is ICMP flood. ICMP echo request and responses are typically used to ping a network device in order to check on its connectivity. Basically, the ping command is used here, through which we can check whether the network connectivity is okay or not. And overall health of the network and strength of the link is checked here between the sender and the receiver. And in this case, what is happening? Basically, networks are forced to respond to request packets with an equal number of reply packets when they flood targets with requests. And as a result, normal traffic cannot reach the target. So if the intruders came into the network, then automatically the normal user, the authenticated user, could not reach the target. Means the target, maybe the target server, maybe the target client. The second one is TCP-SYN flood. In contrast to the traditional networks, clouds basically operate client services inside the virtual machines, making the distributed DOS attacks more harmful. But if one virtual machine in a shared environment becomes overwhelmed, the flood assault will impact all virtual machines there as well. In general, what is the role of the TCP? TCP establishes a secured communication between the sender and the receiver, basically the server and the client. If you go to the practical field, then you will certainly see that there is server and client architecture is most of the cases we are using. So what is happening there? In TCP, in general sense, in TCP, to establish the connection between the client and the server, it requires, mainly the TCP requires three-way handshake. The client sends a sync message, SYN sync message to the server to start a connection. In turn, the server sends the sync acknowledgement. In between this sending of the acknowledgement and sending of the sync message, in between this phase, the attackers are there. They generally wait for this. What is happening? In this case, uh, basically attackers take the advantage of weakness of three-way handshaking process to launch their attacks and prevent uh, the server from serving the legitimate users. In general, they shield, they create a shield in between the server and the client. So this is the basically thing flood. Next is the land flood. Land flood means basically attackers use the TCP-SYN spoofing to send a distributed DOS LAN, means the local area network denied packet with identical source and the destination IP addresses and the ports. That is, the source and destination IP addresses are the same. And after sending a reply to itself, the target machine eventually crashes as it enters a loop. When such an empty connection is flooding a server, a a distributed DOS attack will be triggered. And in addition to destabilizing a device, it prevents the unauthorized users from using it by overloading its resources. So in this case also, the actual users may not get the service properly from the server. In this slide, actually, I just using I just focused the background of my study. Actually, in this point, uh, first a real-time intrusion detection system is required in the early phase. In the early phase of the attack, to ensure that the attack does not escalate and appropriate action can be taken. And most of the statistical distributed DOS detection methods primarily rely on the various consumer standards. And such criteria must be dynamically altered to stay up with the network developments. So day by day there is development. So automatically in that case also, day by day the network dynamically that is altered. And the bulk of statistical methods used to detect flood attacks rely on the computation intensive concepts like entropy, correlation, like that. Hence, they cannot be accomplished in real time. But the machine learning in this case works the best when the rules are applied to small amount of data. And in this case, myself, the author, opted to use the long short-term memory, LSTM, because of the capability of the LSTM to handle the sequential and time-dependent data, basically. And the amount of data that traditional ML techniques, machine learning techniques can manage, however, is one of their main drawbacks. But in comparison with that, deep learning can process and recognize the patterns from enormous amount of data. This is my background of this study. Next, the related work actually. In this work, the author means myself, I have used three different data sets. One is from the Vellore Institute of Technology VIT Cloud Security Research. And these are TCP-SYN, ICMP, land flood attack. And the features of the data sets are, what are the features I have taken here? That is the date, the UTC time, and the relative time, absolute time, delta time, destination, the protocol I am using I have used their lane, source port, destination port, cumulative bytes, MAC address of the source and the destination, unresolved destination port, unresolved source port, etc., etc. Now, number of features in TCP-SYN is 21 and instances is 3,27,000. In LAN dataset, LAN data, number of features I have taken 21 and the number of instances is 7,200. And the ICMP, in that case also, my feature set number of features is 21 and number of instances is 3,87,000. This is my proposed model basically. In this case, I have different utilized. I have utilized the basically this is called L4D, means 4 dense layers, D1, D2, D3, D4 on top of the 100-dimensional LSTM, and consequently I got the result. And as per my result, different machine learning algorithms are used here. One such as multi-layer perceptron, random forest, support vector machine, and hyperparameters are used. Suppose in MLP, batch size is 100, hidden layers is 2, and learning rate is 0.4. In case of random forest, batch size is 100, number of iterations 100, seeding is 0.1. And SVM, batch size is 100, cache size is 40, E.001, delta 0, kernel type linear. Now this is the very small part of the result analysis in this case. First is the confusion matrix for the 3 types of attacks for classification of the using LSTM. So normally ICMP, through the ICMP flooding, in case of flood, we have 3,48,028 packets. But in normal, it is the attack is in case of normal, it is 1,000, generally 1,772. In normal case 49 flooding, and this is the normal dataset rate, and model performance measure for all the 3 types of attacks is like that. Accuracy factor in ICMP is 0.995 and TCP-SYN is 0.982 and the LAN is 0.98. Now this is my statistical evaluation. So this is the model performance measure. This is the model performance measure of the 3 classical machine learning classifiers for all the 3 types of attacks: ICMP, TCP-SYN, and LAN. In case of ICMP, we have used MLP, RF, and SVM. In the same these 3 methodologies used in TCP-SYN and LAN as well. It is the graphical representation of the statistical metrics. The first one, the left side, the first one is leftmost is the ICMP flooding, the middle is TCP-SYN flooding, and the right one is the LAN flooding. This is my conclusion part. So in this case, I have used deep learning based approach in LSTM, and effectively, already I have shown it, that effectively uses the reasonable ensemble features selection techniques to you choose the most appropriate features. And I have worked with 8 features, and the accuracy obtained in between the 98 to 99.5% with this proposed LSTM model. So in this case, basically, I have used deep learning to identify the known attack. But in future, I have a plan to develop models to identify both known and unknown attacks in the health cloud environment. These are my the references where I have used here 20 near about 20 references. Thank you for listening my presentation.